right triangles. One of them is the 45, 45, 90 right triangle. 45, 45, 90 triangle. The 45, 45, 90 refers to what? What do you think?
2 45 angles.
Say it, Hallie.
2 45 angles and then the 90 angle.
All right, so let's draw that out.
It's all lines up.
In a 45, 45, 90 triangle, the two acute angles have a measure of 45 and 45, as well as the 90-degree right angle as well. Now, in terms of the side lengths, what would have to be true about this triangle? Not quite.
It equals 180.
Yeah. How about the side lengths, though? Look at the side lengths.
So like two have to be like equal in the hypotenuse.
Okay, so the two legs are the same, is what you're saying, right, Parker?
Yeah.
Why would that be true?
Because
If the two angles are congruent, the two side lengths opposite those two angles would also be congruent. From the top 45-degree angle, the opposite side length is this bottom leg. From the right 45-degree angle, the opposite side length would be the left leg. So these are both the same. Let's call them x. Let's call them x. I know two lengths, they're both given as x. I want to know, in terms of x, what would the hypotenuse length be? Well, how can I figure out the side length of the third side if I know the other two already? Pythagoreans. A squared plus b squared equals c squared. X squared plus x squared equals c squared. We're going to try and solve for the length c, the hypotenuse, in a 45, 45, 90 right triangle. X squared plus x squared equals that length of the hypotenuse, c squared. I know that the two legs are congruent because we have two congruent acute angles. So I've labeled both of those two side lengths as x. I'm going to give those in terms of x. Now let's figure out what the hypotenuse would have to be in terms of x as well, using Pythagorean's theorem. Does that make sense so far? Okay. Let's solve for c. We're trying to solve for c. What's x squared plus x squared?
x to the 4th.
That's x squared times x squared.
2x squared.
I'm smart. Yep.
Parker, I said the same thing as you at first.
How do I solve for c if I have c squared?
Square root.
Square roots. So c equals the square root of 2x squared. Let's see if we can't simplify that. The square root of x squared times the square root of 2. I'm just going to separate those out as two different radicals. The square root of 2x squared is the square root of x squared times the square root of 2. What is the square root of x squared?
X times x.
So the square root of x squared would then be just
X.
x. Square root of 2, can't please simplify. The hypotenuse in a 45, 45, 90 right triangle is just the length of the leg times an extra square root of 2. What I'm trying to diagram out here too is this. Hypotenuse equals the leg times an extra square root of 2. Let's see if we got it. If the leg is 5 inches long, how long is the hypotenuse? If x is 5 inches, if the leg length is 5 inches, how long is the hypotenuse? 5.
Square root 2.
Square root of 2. It can't be the same thing because this side's longer. It's the longest side part. If the leg was 5 inches, how long is the hypotenuse?
Why would it be square root?
We just proved that using Pythagoreans.
No, I mean like if you do like the two sides, like it'd be like 5 squared plus 5 squared.
Right, so 5 squared plus 5 squared is 25 plus 25, making 50. C squared is 50.
Yes.
The square root of 50 it can simplify down to 5 root 2.
Oh, no, that.
So keeping that in mind, I have a shortcut.
Oh,
If the legs are both 5 inches, how long is the hypotenuse?
Should have done that.
Give me 5 what?
5.
5 square root of 2. Good. Let's try some more here just to make sure we got it. If the legs were both 3 inches long,
3 square root.
you got it.
Yeah.
To find the length of the hypotenuse in a 45-45 triangle, take the leg length times an extra square root of 2. The hypotenuse length is the leg length times an extra square root of 2. Feeling good about that?
Yeah.
Let's do the next special right triangle. 30, 60, 90. Triangle. A 30, 60, 90 triangle. Once again, what do the 30, 60, 90 probably refer to? The angle measure. So let's draw a 30, 60, 90. Actually, I'll tell you what, let's begin by drawing an equilateral triangle. I'm sorry, this is a little bit different.
Bruh.
This is an equilateral triangle. All the sides are the same, so therefore all the angles are the same. If all the angles are same, how big is each angle measure? If all the angles are equal in a triangle, how big
It's
would that
60.
angle have to be?
60.
Oh.
Why 60 now?
Because if you take 180 divided by 3,
So I have 180 degrees to split up and go evenly across 3 angles.
Yeah, I just had.
So 60, 60, 60. I'm going to bisect the top angle. If I cut the top 60-degree angle in half, how big are each of the 2 pieces?
30, 60, 90.
Right. So on this right or left side is a 30, 60, 90 right triangle. I cut an equilateral triangle into 2 separate triangles on the left and the right, and now they're each 30, 60, 90 triangles. Cut the top angle of 60 and a half, now it's 30. There's a 30, 60, 90 right triangle.
What's that down to?
Just a little bouncy. Are the 2 legs the same length? Here's one leg, here's another. Are these 2 legs the same length as they were for the 45-45?
No.
No. There's what's called the short leg, or SL, sure. The long leg, and the hypotenuse. In a 30, 60, 90, the 2 legs are not the same like in a 45-45 leg. So we're going to call them short leg and long leg. Let's start with the short leg. I'm going to call that length X. If half of one side is X, what's the whole length of one of these 2 sides in this equilateral triangle? If this side length is X, what's the whole thing?
X.
2X.
Yes.
X on the left, X on the right. The whole length across the equilateral triangle would be twice that, 2X. I know the short leg is given as X. The hypotenuse would there be twice as long. How can I find the long leg in terms of X? Agree. A squared plus B squared equals C squared. X squared plus B squared equals 2X squared. I cut this side in half, so the short leg is given as X. That's half of one side, so the whole side, the entire hypotenuse, has a length of 2X. Let's plug the X and 2X into Pythagoreans to find, in terms of X, what's the length of the remaining side, the long leg. X squared plus B squared equals quantity 2x squared. What's 2x times 2x? What's 2x squared? 4x squared. What's 2 times 2?
4.
What's x times x?
X squared.
So 2x squared is 4x squared. We're trying to find that missing length. I called it B, that long leg, that third remaining length of our 30, 60, 90 right triangle. How do I, oops, put a plus there, I'm sorry. How do I keep solving for B? So if I have 4x squared and I take the x squared away, what does that leave me?
4x.
4x squared minus 1x squared leaves me what?
3x.
I heard 4 and I heard 3x squared. Which one's correct? 3x squared. There are 4x squareds, and I take an x squared away. Now that leaves me 3 of the x squareds that I started with. 4x squared minus x squared is 3x squared. Altogether, there are 4 of these x squareds. I subtract 1 of them away. What's left? 3 of the x squareds. Okay, what's next? Square roots. That leaves me b equal to the square root of x squared times the square root of 3. You got it.
Yeah.
So the long leg, we're trying to find the length of in terms of x. It's given as x root 3. Yep. Every single 30, 60, 90 triangle, the hypotenuse is twice as long as the short leg, and the long leg is the short leg times an extra square root of 3. So to write that down, that's a good idea to keep in mind. In a 30, 60, 90 triangle, the hypotenuse is double the short leg. The long leg is the short leg times an extra square root of 3. The short leg is x, the hypotenuse is twice as long, and the long leg is that short leg length times the square root of 3. Let's play a similar game. If the short leg is 5, how long is the hypotenuse?
5. Oh,
Yeah,
no.
it's 10.
My bad. Oh.
5 times 2 is 10. Blah, blah, blah.
What's the long leg?
5 root.
So given one side length, I can find 2 of them. As opposed to Pythagoreans, where I had to know 2 side lengths in order to find the one remaining side length left over. It's a shortcut because there is a special property across all 45, 45, and 30, 60 triangles in terms of their side length. All I need to know would be one of them to find the other 2 sides. Special right triangle.
What the fuck?
That's just something things I'm office. Office opening his own office. What do you mean?
My hair's always wet.
He's opening his own office. So, I mean, you should same thing Barack Obama. Like he's better. You don't have to explain to me what you mean by office. Basically, I'm saying since Donald Trump is retired, he has some type of president office shit. Since he used to be president of the United States, he's going to open
let's
it,
do it.
which is usually what presidents do. Previous presidents do. Since they're-
Could you tilt the screen a little
Yeah, I'm
bit?
sorry, I was just
He's
going to check
to
that.
open that.
Okay,
It's a bit
thank you.
2 times bigger.
Trey, could you return to your desk?
But the problem is,
Keeping those other 2 diagrams on the board for our 45, 45, and 30, 60, 90 triangles. Let's find some missing lengths given in these types of triangles. first example up, I want to run through a couple of these. What type of special right triangle is that? Is it a 45-45 or a 30-60? 45-45. So we're talking about the first of our two special right triangles. I have one side length given. 3 square roots of 2. Is that a leg or a hypotenuse?
Leg.
Leg. In a 45-45, the 2 legs are the same. The hypotenuse is that length of the leg times an extra square roots of 2. So what would A have to be for its length?
3 root 2.
Because the 2 legs are congruent. Now the hypotenuse is going to be longer. Longer by what? What do I multiply
X.
the leg to get the length of the hypotenuse? Square roots of 2. I take 3 square root of 2 times an additional square root of 2 to find the length of the hypotenuse. B equals 3 square root of 2 times an extra square root of 2. What's the 3 square root of 2 times an extra square root of 2?
2.
Well, that's the square root of 2 times the square root of 2, but I also have an extra 3.
So 6.
6 altogether, I agree.
Yeah.
There's 3 numbers to multiply all together. Let's pick 2 of them first. Luke said square root of 2 times the square root of 2 was an extra
2.
2. Then take that 2 times 3.
6.
You're so smart.
Times 3. Let's try some more. Here's an extra example. Let's do some more practice with 45-45 triangles. I know this is a 45-45 triangle because why? Maybe I should start with that first.
One of the angle is 45.
Right.
Which means
So it's important to know what type of triangle this is. This is a 45-45, right?
yeah.
All right. So the relationship for the lengths of a 45-45 triangle is this. So 2 legs are the same. The hypotenuse multiplied by an additional what? Square roots of 2. Is this 12 a leg or hypotenuse? It's a hypotenuse. So rather than taking a leg to find the hypotenuse by multiplying by a square root of 2, I have to find the hypotenuse, take it down to one of the 2 legs. What do I have to do?
You have to like divide it by 2.
Close, divided by square root of 2. To go from leg to hypotenuse, multiply by the square root of 2. So to go from hypotenuse back to leg, I have to do the opposite. Rather than multiplying by the square root of 2, I divide by the square root of 2. So A, leg, would be to take 12 divided by the square root of 2.
It's actually 6 root.
How do I divide by the square root of 2? I actually multiply by something. How do I get rid of the square root of 2 in the bottom? What would I have to multiply by?
2.
Close. Multiply by the square root of 2. Because like Luke said, when I take the 2 denominators and multiply them together, what's the square root of 2 times the square root of 2?
2.
So this would be 12 root 2 over 2. 12 times the square root of 2 is 12 root 2. Root 2 times root 2 just makes 2. What did you say, Parker? Sorry.
That's 6 root.
How are you getting 6?
12 divided by 2.
12 divided by 2, I can reduce that down. That's just 6 root 2.
Yeah.
How long is B?
6 root 2.
Why?
Because 6 root 2 times root 2 is.
No, B, the other leg.
Oh, because they're
They're the same.
equal.
All right, tell you what, let's do one more. We haven't done a 30-60 yet. Let's try one of those. Alright, so I've got another right triangle up on the board. Is that a 30-60 or a 45-40? 30-60. So in a 30-60, we have 3 different types of side lengths, a hypotenuse and 2 legs, a short leg and long leg. The 16 we're given, is that a leg or a hypotenuse?
Hypotenuse.
Why do you know, Mace? Why is that the hypotenuse? The biggest one, it's opposite the right angle. This would be the hypotenuse. We're going to try and find the other 2 legs. I'll call this leg A, this leg on top B. Perfect. In a 30-60, the 2 legs are different lengths. They're not the same angle. I don't have 2 of the same angles like in a 45-45. Which one's the long leg, A or B?
B.
It's the long leg because it's opposite the bigger angle. The side length opposite 60 is going to be bigger than the side length opposite 30. So I'm going to label this LL for long leg and SL for short. We have some statements over here for our work on identifying the relationship for these side legs. The hypotenuse is 2 times the short leg. Hypotenuse is double the short leg. The long leg is the short leg times an extra factor of square roots of 3. Macy said we're given a hypotenuse of 10. I'm sorry, not 10, 16. We're given a hypotenuse of 16. How long would the short leg be if the hypotenuse is 16?
8.
Why 8? I agree.
We're divided by 2.
Divided by 2. I'm going backwards. I'm trying to make it smaller. The short leg to the hypotenuse means multiply by 2. So from the hypotenuse to the short leg, you divide by 2. What double makes 16? 16 divided by 2 is 8.
Then B would be 8 squared root of 3.
Say again, AJ?
Then B would be 8 squared root of 3.
AJ is saying that B is 8 square root of 3. Is that correct?
Yeah.
Because the long leg is the short leg times the square root of 3. I know the short leg is now 8. What I did first, now take that 8 times the square root of 3 to get your long leg. All right. Today and tomorrow, we're going to get real good at special right triangles. We're real good at special rights. Let me pass out some practice, and I'll pull it up on the television screen as well. So, yeah, Michael, please.
B just equals 8 square root of 3. No, I'm sorry.
8 square roots of 3, you bet. If the short leg in this 30-60 is 8, the long leg is just that 8 times an extra square roots of 3. The long leg is the short leg length of 8, but put an extra root 3 on these. Looks like on this practice, we've got a whole bunch of 30-60s and 45-45s, right, to try on. There's also a section on Khan Academy online on special right triangles. I try a few here first, just to make sure you know what you're doing. Ashton and Maddie, let me share my screen and pull it up on Classroom. You guys doing okay so far?
Yeah.
Yeah,
All right. Perfect. And Maddie, you said you're going to be back this week. Is that right too?
it should be next Monday.
Okay.
Yeah, I'll send
Sounds
out
perfect.
an information email.
Let me know if that changes. Under Classroom. I've linked all the practice keys under this resources doc here. Today and tomorrow, we're going to be looking at these special right triangle links here. Special right triangles here, and multi-step special right triangles down below. You can find the same practice I just passed out with this link here. Did I show you guys how to find your overall grade on Google Classroom on Monday?
I kind of figured it out.
Yeah, I already looked.
Okay.
I just
I put all of your guys' grades on Google Classroom from the first unit on similarity. If you're curious what your overall grade is, pull up Google Classroom and I can show you where that's at. Yeah. I put the letter grade on Infinite after our first unit, and you can also keep track of your overall grade on Google Classroom. Google Classroom is generally more current than what's on Infinite, though.
Wi-Fi together.
You gotta open my snap to check the 2 snaps that I sent you. They're pretty funny.
You've got 3 numbers. You get 2 of them first. Extra square root of 2. So you took 2 square root of 2. You took a leg length of 2 times an extra square root of 2. You did exactly what you were supposed to. Just simplify that down.
Let's do it on one of these.
If I have Wi-Fi still, someone else.
80%.
I'm not even gonna try.
If anybody wants to do a reassessment on their first similarity quiz, I have those ready too. We could take that in class today, tomorrow, or Friday. Just let me know, or you can come in outside of class too. Oh shoot, I'm sorry.
If I reassess and I get the problem I missed right,
Then it would improve your grade, right? I'm only gonna have you reassess on what you missed on. So pull out your old quiz and do rework those questions to make sure you know what you're doing. And I can get you the reassessment.
Or half of homework is like.
I don't know. It wants, dude. I found it.
Just see what your overall grade is. And look at your overall grade and see if it would help. Well, then that's up to you. It's your grade.
Yeah.
As long as I get it. Yeah.
I just asked those reassessments if you're interested, or then by the end of the week. So it's not hanging out there. Let me finish.
I'm not gonna do it. How will 3% help my grade? I'm gonna forget my grade.
Something you don't say in school.
I would like to.
Chill, rocking.
I don't like how like half the class is fine. I'll reassess too. I'll do it right now.
I'm trying to be a
I
doctor.
don't have my test though, hope you don't mind.
Then I don't know what to give
I'm
you
going
though.
to be a nuclear.
I find that
I know
test.
the quick time is.
What's that?
I know the flyers I actually bought don't have my papers, so I don't know if she did my parents.
Yeah, some type of business. Hey, why'd you steal my pencil?
Which ones did you miss?
You just left it here, and I don't know. Kind of, I kind of absorbed it. Oh.
Yeah.
Well, I'm gonna need that back. No, here's your pen. Nope. Yeah.
Just put your work in.
Hey, can I have my? That's handprints. Grab me another one.
Once you put that away.
What is the date?
Today is the 27th.
7. Soccer meeting at.
Jan 27th.
There's a soccer meeting for girls.
4
at-
divided by the square
Around
root.
512, 100-meter dash.
Right?
That would give an eye.
Yes, I can't.
Times the top, bottom by
Powder and all the paint just comes out.
Square roots of 2. Because now when I multiply the square roots of 2 times the square roots of 2, that again,
It's just so up.
then the square root formates
Most
2.
of our games are gonna be at like 6.
You should.
42 times the square root of 2 is just a 2.
I should go out.
The square roots cancel out. Now on top, I have 4 times the square root of 2.
We'll just see, just show up, say I might be able to come up.
So smart.
Baseball and track.
Put your hands in.
I've added leadoff and played second base.
Okay, I'm
And
done.
track,
Can you check it right now?
I I got 400 open.
Well,
And the rest.
Wait, where'd you go to school?
If you know.
Yeah, you do kind of look like a long distance runner.
Well, I don't have the same body frame that I used to have when I was 17 years old.
Yeah. I should totally go to one.
Looks like you enjoy tennis. She does not ball. I'm terrible at tennis. I'm telling you, it's way harder than it looks.
My dad played tennis in college. He was really
My
good.
dad
I
was
He got
like,
an All-American award for competition.
There's something that we
And tennis. He's talented. He's actually really good. And golf.
Yeah.
I love it.
dude, golf is a legendary.
My dad's super bad at golf. Okay. He's
Put your name on it though for me.
My dad's a pro at golf. I should go out for golf, you know. I'm terrible.
We figured out and give you an scholarship class, okay?
Thank you.
It's not like I just go golfing.
Your most current grade is typically what's gonna be on the
Problem
class.
is, I don't take my time. I just get up there and hit. That's like,
I'm good. Usually I take too long. My mom's like, today.
and I also don't usually follow through, so it ends up going all the way over to the left
We're doing some con work.
or the right.
It's fun. I'm
So,
so.
we,
Then
so
every
you
once
just
in a while,
know.
There's also an app on your phone. That's something you
Oh no, I
Yeah.
don't even do a half.
I
I always do a
download
full.
Just make sure you sign in with the same
Just
email
like,
account.
don't follow
I'm
through.
probably.
Yeah.
I'll sign with
No,
that.
I mean like you're supposed to move your hips too.
Yeah.
Like move your hips through.
Some people like that better.
I hate the
Learn
glove
how-
kind of like
learn how-
that.
learn how to
Instead of
dance,
straight
but not the-
I still remember actually doing
curves or like it's
getting off work and all that.
or books.
Physical science.
All of them's covered.
So the hypotenuse.
Easy question.
I want to work backwards and find the two legs.
I don't know why we.
Parker,
never
why'd
do
your
physical-
TikTok show
The
up?
hypotenuse is the leg
Because
times the
I'm
square.
famous.
Well, I want to take the
Hundred
leg
and
of the
one likes.
hypotenuse,
Much.
multiply it.
Literally,
So I want to take the hypotenuse and go back
Well,
on my leg.
it's
I do the opposite.
Fuck you.
Go the opposite of both.
Did you
sides.
open my TikTok? No.
I need to take
Open
four.
page.
Open
the two videos. Turn the volume down because that shit is loud. All right.
I'm by the same root two. So what is root two times root two? 2. So on bottom, all I have now is a 2. On top, 4 square root. Does that make sense? Both legs are 2, x and y are both 2 radicals. I was just doing that.
Yeah, I was kind of paying attention, but I wasn't entirely sure. So,
Okay. In a 45-45, the hypotenuse, the length of the leg times the square root of 2. If I want to find the hypotenuse, I take the leg times the square root of 2.
but
Now I have the hypotenuse. I have a length of 4. How do I take the hypotenuse and go back to find the leg?
you have to take the leg divided by
Uh,
no.
I lost 2 previously.
I work backwards. I do the opposite of multiplying by root 2.
I did it.
What's 4 divided by root 2? How do I simplify that?
27%.
Multiplied by 2.
Multiply by root 2. Whatever radical's on bottom, Hallie, you need to multiply the top and bottom by the same thing.
Yeah.
So divide by the square root of 3, multiply the top and bottom by the square root of 3. Divide by square root of 5.
Did you watch the one with like
What's
the
root
box
2
of
times root 2?
chocolates?
4.
I don't think
The
that's
square root of 4, which is then just what?
2.
I should have.
Those two radicals multiply together, square roots cancel out.
Yeah.
On top, I have 4 square root of 2. I can simplify it. What's 4 root 2 divided by 2?
2 root 2.
My both legs, x and y, are the same. You just have a length of 2 radicals. Maddie, Ashton, something I can help you guys with as you're getting your practice going here?
I'm doing all right.
Okay.